So we're seeing a vast increase in customer demand post-pandemic, with civil aviation recovering far quicker than anybody thought it would. The parts we make are very complex, particularly the fan case. There's around 1,800 individual fitting operations on a fan case. Really important to help with the throughput and the delivery to our customer that we seek efficiency and productivity improvements in this area to help our people that manually build these engines.
Manufacturing needs to change. One of the ways we can achieve this change is through the use of digital tools. Within Factory 2050, we work with both large multinational organisations and small SMEs as well, to support them in providing them demonstrations of the digital transformation.
Factory 2050 are a founding member of the Industrial Strategy Challenge Fund Industrial Consortium. The purpose of their role in this picture is to provide the industrially-led consortium with a pre-production facility with which to develop, pioneer and de-risk digital enabling capability.
So we've been working with Rolls-Royce to explore how we can take their CAD information in JTs and their digital work instructions into a light version of a digital thread. So we've been exploring with Siemens a deployment of Teamcentre and Opcentre into our Azure Cloud, so that is the product lifecycle management and their manufacturing execution system, to understand how we can develop work instructions through into the execution environment, through into the devices that we've been exploring within this research programme. So we've been looking at HoloLens, smartwatches, tablets, projection, as well as what is available out of the box from the Siemens ecosystem to enable these sorts of devices. We've discovered that the productivity improvement could be up to 37% for these types of digital work instructions. Some of that benefit does come from having devices close to operators on the shop floor in their workstations, so smartwatches, tablets, but really it's about enabling operators and fitters on the shop floor to have the right device that is suitable for them, to have the right type of information that they need at that point of consumption.
Particularly where we've got inexperienced fitters who might not be quite so familiar with some of the operation sequence, I can really see how this would help them in assembly of the engine. Certainly in having all of the relevant information at the point of use, so not having to walk away from the job to a terminal to digest the information and then come back again. It's got huge opportunity for time saving, but also in terms of the quality of the work that they're producing. By actually having the information right in front of them, particularly some of the augmented reality and the overlaid information, you can see exactly what it is that you should be doing, and it eliminates the opportunity for mistakes.
So we've got some great opportunities within assembly and test to implement this technology, which is really exciting for us.
This is a really interesting proof of concept experiment for instructions at the point of use. It's been very valuable in showing what is possible, but also the areas that we wouldn't want to explore any further. And it's clear opportunities to implement this in the PTF or in Dalovitz at a future point in time in assembly and test in Rolls-Royce.
Working with the AMRC as a centre, we're able to bring in requirements from all over the Rolls-Royce group, not just the assembly and test business or the fan case application, and use that to be able to de-risk before we implement this technology throughout the group.
Now at the end of this project, we're looking at how we can explore the benefits across the Rolls-Royce estate. We're looking at how we can have a connected shop floor, looking at approaches like digital twins, looking at the digital thread that this now enables, looking at how the devices can feed the information into these business solutions. We're also looking at more of a personalised experience of fitters, which can increase productivity, can increase quality, and also can increase sustainability by having less waste.